Okay. Students, now in the state space analysis, we just see the how to find the state equation and output equation from different models. Okay. Now from the block diagram, how to find, from the signal flow graph, how to find, from the transfer function, how to find, from the differential equation, how to find, which we already covered, right? Now in the same manner, now this is one more thing, how to find the state space model, means finding state equation and finding output equation from the electrical circuit, from the circuit which is given, now which is a combination of RLC components, and he is asking to find state equation and output equation is nothing but a state space model is nothing but a finding state equation and output equation. So when the network is given, when the circuit is given, so you follow this procedure. Now actually any model we have to identify the variables. Okay, state variables are 1 or 2 or 3, whatever it may be. Okay, so select the state variables as voltage across capacitor as a state variable, or current through the inductors as a state variables. Okay, when current is passing through the inductor, now that current is also treated as a state variable, or across a capacitor what should be the voltage, that is also taken as a state variable. Next, so you already know that the number of state variables is nothing but inductors and capacitors, because the storage element state variable represents the memory. Okay, so the number of state variables is nothing but the number of inductors and capacitors. Okay, that is the first point, you know that already. Now second thing is apply KCL and KVL equations now at capacitor junction and through the inductor. Okay, means in the loop you write a KVL, at junction you write KCL. Okay, next, and whatever the equations you are writing, that equation should be in terms of state variables, because you know that the state equation is saying that this is the state equation. The first derivative of state equation can be expressed in terms of state variable and input, and output at any instant of time can be expressed as a state variable and input. This is state equation and output equation. Now, so this is a circuit which is given. So this is the junction. First we will follow this step. Variables, we will find variables first. X1, X2, X3. Let us say this X1 as VC, voltage across capacitor. Now this X2 as current passing through the first inductor IL1 and current passing through the second inductor IL. Okay, so this is the three state variables X1, X2, X3 and VC, IL1 and IL3. Okay, so you know that the three state variable means definitely a matrix order is also 3 by 3, right? So at junction, if you write equation, now if you write a KVL at junction, if you write KCL, now which is nothing but this is leaving current minus IL1 and this is leaving current, all are leaving, sorry, this is entering current and this is leaving current IC, and this is also the leaving current, one entering current and two leaving current, which is nothing but IC, which is equal to IC, which is equal to IL1 minus IL2. Okay, IC which is equal to IL1 minus IL2, and now KCL, right? This is KCL. Now KVL we write in this loop equation. Now this is the current which is already taken IL1. This is the current which is already taken IL. Now what is this? Now minus VI plus IL1 R1 plus L1 into DIL1 by dt plus VC, which is equal to 0. Therefore, which is nothing but Vc, which is equal to, now this is the equation. So I want IL1, right? IL1, which is equal to Vi by R1, Vi by R1 plus Vi by R1 plus Vc minus Vc by R1 and minus L1 by R1, okay, minus L1 by R1 into IL1 dash, right? Okay, this is clear. Now the second loop equation is minus Vc plus IL2 R2 plus L2 into dIL2 by dt, which is equal to 0. IL2, which is equal to Vc by R2, minus L2 by R2 into IL2 dash. Okay, right. Okay, is it right? So now we'll write the state equation Vc. What is Vc? Vc is nothing but now here Ic is nothing but C into dVc by dt, which is equal to IL1 minus IL2. So dVc by dt, which is equal to 1 by C into IL1 minus 1 by C into IL2. So Vc dot IL1 dot IL2 dot, which is equal to Vc IL1 IL2 plus, now this is input Vi. Now see here, now in terms of Vc, this is 0, Vc dash is 0. Now IL1 means 1 by C, IL2 means minus 1 by C. Now in terms of Vi is also 0. Now IL1 dash is nothing but Vc is minus 1 by R1 minus 1 by R1 minus L1 by R1 minus L1 by R1. Now L2 is 0. Now here is also A is 1 by R1. Right, IL2 is VC is 1 by R2, and this is IL1 is 0, IL2 is minus L2 by R2, minus L2 by R2, and VI is also 3. Now this is A matrix and this is B matrix. Now what is output equation? Output equation is nothing but V naught. What is V naught? V naught, which is equal to IL2 into R2. So this is the output equation V naught, which is equal to into VC IL1 IL2. Now V naught in terms of is 0, IL1 is 0, IL2 is R. Okay. Now this is a state equation, and this is output equation. So this is the state equation and output equation. Note down. In this equations, we'll do some small mistake here. Now see here. So what we want? We want IL1 dash. IL1 dash is this. What is IL1 dash? IL1 dash is nothing but minus VC by L1 minus IL1 into R1 by L1. Now plus VI by L1. This is IL1 dash. Next, now here we want IL2 dash. IL2 dash, which is equal to IL2 dash, which is equal to plus VC by L2 minus R2 by L2 into IL2. That's it. This is IL2 dash. This is IL2 dash. So this is again IC is C into D, IL1. Okay. This is VC dash, which is equal to 1 by C into IL1 minus 1 by C into IL2. Sorry. Okay. So this is the equation. So there's a small change here. So 0, 1 by C. This is correct. But IL1 dash is this is a small change here. That's it. Only a small variable. So IL1 dash is nothing but minus 1 by L1. Now minus R1 by L1. Therefore, this is 0, right? Now this is correct. Now 1 by L2 minus R2 by L2 0. Sorry, this is 0. This is minus R2 by L2 and everything is cut. This is IL1 dash is nothing but 1 by L1. Or in terms of R1, now just write L1. That is the only thing. Okay. So I just explain once again. Listen carefully. So first identify the state variables. Okay. Identify the state variables means the state variables is nothing but voltage across capacitor or current passing through the inductor. Therefore, this is voltage across capacitor. VC is one state variable. IL1 current passing through the inductor, second state variable. IL2 current passing through the second inductor is third variable. Okay. So what we want a derivatives of that state variables means dx1 by dt, di1 by dt, dvc by dt, dl1 by dt. Therefore, that's why this is at junction IC. This is IC, which is equal to IL1 minus IL2. What is the current passing through the capacitor? C into dvc by dt. dvc by dt is nothing but vc dash. This is IL1 dash. This is IL2 dash. Okay. So you know the state equation and you know the output equation. Okay. So this is matrix A. This is A matrix. A matrix order is always n by n, where n is number of state variables. This is B matrix. B matrix order is 3 by 1, n by 1, where n is number of state variables. Now this is C matrix. Now C matrix order is 1 by 3, 1 by n, where n is number of state variables. Okay. So this is the way we can get the state equation and output equation now from an electrical circuit which is given to you. Okay. Note.